Hey, yeah.
An important topic of thermochemistry is Hess's law of summation. And the Hess law describes when you have a multi-step reaction, that you can take the reaction from step 1 and step 2 and simply add the change of energies together to get the overall change of energy. Hess's law is defined as the change of H of an overall process, the sum of the enthalpy changes of its individual steps. Hess's law uses an overall reaction as the sum of a series of reaction steps. Hess's law becomes really valuable when considering a reaction that can't be done in the laboratory, or that's a bunch of some multiple steps or multiple process. Most entropy values can be found on a chart. The oxidation of sulfur to sulfur trioxide is the industrial process to make sulfuric acid, and one of the byproducts is acid rain. Consider the following reactions. Most literatures will provide you with the change of enthalpy for most simple reactions. Now, if this question is asking us, what is the change of enthalpy as S is added to 3/2 equivalents of O2 to produce SO3? And if you look at the reactions that are given, reaction A gives us sulfur that's burned in the presence of plenty of oxygen to produce SO2, and it gives us a change of H of a negative 296.8 kilojoules. But then you must take, in reaction B, 2 equivalents of SO2 plus oxygen. 2 SO2 was burned in the presence of oxygen to produce 2 equivalents of SO3, and has a change of H of negative 198.4 kilojoules. The problem with this is that you cannot have a reaction from sulfur to SO3 and all at once in a calorimeter. So you must conduct one reaction and then the other. But what's the overall change of H? This is where Hess's law becomes important. And the Hess's law, it's the law of summation. So all we have to do is add this change of H for that reaction, the change of H for reaction B, to get the change of H for reaction C. But we must manipulate the reactions so that when I combine them, they look like our overall reaction, or some literatures will call this the target reaction. So let's have a look at reaction A. Reaction A has sulfur in the reagents, and our target reaction has sulfur in the reagents. So that looks pretty good. I also got O2 in the reagents, but I've got 3/2 in the reagents. Well, let's see what else we can do. Reaction B has O2 in the reagents and O2 in the reagents. Okay, well, let's keep going. We see SO3 in the products and SO3 in the products. That's good, but if you notice, reaction B has 2 equivalents of SO3. That means I got to get it to look like this. I've got to get 1 equivalent of SO3. So you ask yourself, what times 2 is 1? 1/2. You multiply the entire reaction by 1/2. And this is where thermochemistry relates to stoichiometry. When you change the stoichiometric coefficient, you must change the amount of energy that is absorbed or released, and in this case, negative value. And this guy, wasn't it? 1/2 times the entire reaction. 1/2 times 2 is 1 SO2 plus 1/2 O2 produces 1/2 times 2 is 1 SO3, and our delta H of reaction B becomes half of negative 198, which is negative 99.4. Let's examine what we have now. I've got this new reaction with one equivalent of SO3, which looks like our target reaction, which has one equivalent of SO3. Now we can combine the two reactions. I will erase one of the reactions to give you some clarity. Thermochemistry happens to be long-winded because there's a lot of terminology associated, but it's simple algebraic process. So if I'm examining reaction A and reaction B, you want to see what do we have on the products versus the reagents. Reaction A has SO2 in the products. Reaction B also has SO2 in the reagents. So when you combine them, this essentially cancels out. Once again, I've got SO2 here and I've got SO2 here. This is reagents, this is products. Therefore, it cancels. Can we cancel anything else? No, not really. So now let's get on with the law of summation. Summation. Let's add them together. So I've got one equivalent of sulfur in the reagents, one equivalent of sulfur. I got one equivalent of O2. One equivalent of O2 plus 1/2 equivalent of O2. 1 plus 1/2 is 3/2 O2. And it produces what's left over as our SO3. All we have to do now is add our change of H's. Negative 296.8 plus negative 99.4 will give us our new change of H. Our new change of H is negative 396. I encourage you to seek different sources of literature. I did get these sample questions from a very prestigious author, but if you were to do practice problems from different texts, different literatures, they explain it from different perspectives. This will help increase your comprehension. Let's take another example using Hess's law.